Hello everyone and welcome to another video covering the OCR Computing GCSE course. Today we're looking at topic number 4, which is all about memory, different kinds of memory, the function of different kinds of memory, and there is a lot of information in this video, so I'd recommend you pause it periodically so you can read over it and make sure you understand what I'm saying, because some of this stuff is, well, yeah, it may be new to you, so it's good to consolidate what you've read. So firstly, we're going to sort of compare two types of memory, which people like to compare for whatever reason. I think they're actually quite different. I mean, they are sort of opposites in a sense, but I will compare them sort of. So RAM stands for random access memory, and ROM stands for read-only memory. Two types of memory you've got to know all about. So RAM is a form of memory that has a very quick read-write time. And when I say read-write time, this means this is how quickly things can be accessed from it and how quickly things can be stored on it. RAM is a quick form of memory. Slower forms of memory include hard disks, and faster forms of memory may be a cache in a computer, which we'll actually look at in the next slide. So RAM is a form of volatile memory. A volatile memory means that it actually loses everything stored in it when power is turned off. So if I describe its function, I may be able to explain that slightly better. So the function of RAM is to store all of the data associated with programs that are currently open. So let me give you an example. Okay, on my desktop I've got a Microsoft Word icon. So whenever I double click that, all the data that's associated with it, so all of your programs will have some data, some files stored associated with it. So they'll be stored on your hard drive, usually in your program files directory, and temporarily when you open it, this data will be copied onto your RAM from your hard drive, and this is because RAM is faster to access. So when you open a program, everything to do with it, so accessing it, using it, so Microsoft Word, even small things like changing the size of fonts, changing fonts, everything will be quicker than if you had it on your hard drive. So that's why RAM's used, but however, because it's volatile, it means everything stored in it is lost when the power is turned off. So if you may have experienced this, I definitely have, when you forget to save something, if you're doing an essay, if you're doing a PowerPoint, you forget to save something and there's a power cut, someone turns your computer off, for whatever reason the computer gets turned off and everything lost, all your work suddenly gets lost. People often confuse this because they see on Microsoft Word often you'll have a sidebar that says stuff's been recovered, and this isn't from the RAM, this is Microsoft Word periodically saving stuff on behalf of you. People assume that it means that somehow the RAM is permanent. It's not, it's temporarily stored. What's actually happened is they've saved it for you, the program saved it for you. So that's why RAM's used, it's fast. So generally, more RAM means your computer will be faster to use because you can have more programs used at any given point. And actually, RAM is technically infinite depending on how you like the theory. We're actually going to look at the theory of virtual memory and what virtual memory is in the next slide. So more RAM is better for your computer, but there's no point in having 100 gigabytes of RAM. So the average amount of RAM in a computer might be like 6 gigabytes, whatever. If you have 100 gigabytes of RAM, there's literally no point. Whatever you're going to be doing is not going to use up the 100 gigabytes unless you're doing it for a commercial purpose or whatever. So that amount of RAM is completely excessive. You don't need that amount of RAM. So it's not like a processor clock speed where you can increase it infinitely and the performance will increase infinitely. RAM, there's always a limit, and the limit is forced with how much work you actually do on your computer or how many programs you have open. So if you look at ROM now, ROM is a form of storage that contains pre-recorded data. So if you look at the name, you'd sort of have a hunch what it does. Read-only memory, meaning that the data stored on it cannot be altered and can only be read. You can't change what's stored on ROM. So ROM hasn't got too many functions, but it is a form of non-volatile memory, which means that everything on it is retained even when power is turned off. So ROM is used in very small amounts. So compared to RAM, maybe you'd have, like I said, 6, 8 gigabytes, 4 gigabytes of it. ROM, maybe you'd have only 30 megabytes, maybe slightly more, maybe slightly less, I'm not 100% sure. But ROM is used to store essential programs on your computer. So if you've ever built a computer, you'll know that the operating system isn't pre-installed. I've heard people tell me that they think that the operating system is stored on the processor or some rubbish. It's not like that. if you build a computer, you can turn it on. Hopefully, depending on how you built it, it turns on first time. There'll be a boot menu, and the boot menu is the data for the boot menu stored on this ROM on your motherboard. So if we look at what ROM looks like, that's what RAM looks like. This is RAM slots on a computer. This is 4 little sticks of RAM. ROM is a little square block on your motherboard in small amounts that contain these essential programs. They are often also used in some devices like calculators, but that's just an example. Okay, so now we've got to look at 3 different types of other memory, one of which is virtual memory. And I mentioned this because this is all about RAM. Virtual memory is a memory management procedure that comes into effect when all the RAM has been used up in your computer. So data that's been held in the RAM, some of it gets put on your hard drive temporarily, which means that the capacity of your RAM is extended because you have this memory stored virtually, that was me doing inverted commas, on your hard drive. So it does extend the RAM capacity, but the read-write time of a hard drive is so much slower than the RAM that everything accessed from your hard drive is slower. So the plus point is that it extends your RAM capacity. The negative point is that everything is accessed slower. So the data that gets chosen to be sent on the disk is often that you haven't used recently. So you may, if you have a program minimized that you haven't used in a while, that you haven't maximized in a while, it may take a while to load when you open it up. And it may not even work because it's a good solution, virtual memory, but it's not perfect. So another type of memory is cache memory. I used to always call it cache, sound like a bit of an idiot. Cache memory, because I'd only ever read it. That's my excuse. I've only ever read it. Sometimes when you read stuff on a textbook, you say it in your own way, which isn't often right. So cache memory is a store of data that allows future requests to be served quicker. In the topic number 2, in the CPU video, we looked at processor RAM. So you can have different caches in your computer. An example is in a web browser. So what it does, cache memory is quick to read and write. It's very quick. It's quicker than RAM, which means that everything accessed is very quick to access. So data that's chosen to be stored in a cache is often such that it's frequently accessed. So if we look at a browser example, Google Chrome is quite fast because everything's stored. Because Chrome has quite a lot of cache, which means that your favourite websites you access a lot, like Twitter, Facebook, YouTube, Google, the website data is stored in this little cache. I mean, it's a really small amount. It's a small amount of cache, so that whenever you access those websites, they're quick. They load quickly. They load almost instantaneously, which obviously saves you time for the long run. So finally, we're going to look at flash memory. So flash memory is sort of a emerging technology. It's actually been around since the 1980s, but recently it's been realised that they can replace a lot of the secondary storage that we often use. So flash memory is a type of non-volatile memory, again, which means that it doesn't lose its data when it's turned off. And it uses something called solid state technology, meaning that it has no moving mechanical parts. I think it's really interesting. I don't totally know how it works, I'll be honest, it's very complicated, but it does use the logic gates we were talking about in the last video. So it uses, I believe it uses NAND gates, I'm not 100% sure, so not AND gates, but I'm not sure on that. But it uses all these little logic circuits. I mean, not when I say loads, I mean millions, billions of them, maybe trillions in some cases, of these circuits that allow the data to be stored using binary, which is, I think, is really cool. Anyway, solid state drives are a form of flash memory. You also have memory sticks that you plug into a USB drive. Also have camera memory cards. Bit of a mind blank there. So SSDs, solid state drives, are a form of flash memory that are being developed recently. So 5 years ago, you may not have ever heard of an SSD. Their capacity might have only been 30 gigabytes, but now you can have ones that are a terabyte. Maybe even larger, I'm not 100% sure, but they are really expensive. They're far more expensive than hard drives because they are sort of an emerging technology. So they're an example of how new technology has led to computers being faster, because flash memory storage devices are really quick to access compared to a hard drive. So I would definitely, in 10-15 years, I reckon every computer will have these, and they'll be super quick and have a super high capacity. Anyway, thanks a lot for watching. Rewatch it, pause it, whatever you need to do to understand this, and hopefully you enjoyed and it was useful, and hopefully I'll see you in the next video. Thank you.